Okay, hello everybody. This is tech demo number 4 for Math 2 5Y1. And so let's get right into it. So task number 1 asks us to give the plot of a vector field cosine x cosine y times I hat plus sine y sine x times j hat using a viewing window containing at least these bounds. And you should plot enough field arrows to see how the pattern of the field behaves. So to do this, I used field play, which Professor Lehman showed us in lecture not too long ago. And we can see that we have this sort of like checkerboard pattern of vortices, right? We can see how these like different like concentric circles of the fields within each other, right? So we also notice that each of these like checkerboard pieces is about pi over 2 by pi over 2, right? So what this tells us is that we can see these like little like asymptotic lines between like each of the checkerboard squares, because these were basically one of either the cosine or where both cosine and sine are equal to 0, right? So as such, we just don't see anything right here. And inside the circle, I have this showing from green to red in terms of velocity, right? So we can see that on these little side parts here, that the velocity is the highest out of each of these circles, right? So I guess the last interesting detail to mention is that we can see that if you go to the next square over, the circles are going in the opposite direction. And this is because when you like think about the unit circle, right? When you go past pi over 2, the sign of cosine flips, right? And when you go past pi, the sign of the sign of sine, sorry, that is a tongue twister, but the sign of sine will flip, right? So that's why we're getting an opposite orientation as we go past the pi over 2 limit for each of these, right? So this produces a really interesting and honestly kind of beautiful pattern that we can see, just like, and then field play just allows us to visualize this in a way that pretty much no other tool that I know of allows us to. So yeah, all right, let's move on. Number 2 is plot the torus with central axis the x-axis, radius to the x-axis of 4 and tube radius of 2. So I have this plotted right here, right? So we can see that if we look at this like right here, right, the center of the please stop spinning, thank you. All right, the center of the torus is about right here, and if we turn that off, that's about where 4 is, right? You can like see if I flash it, about the center of the torus is at 4, and we can see the start of the torus is at 2 and the end of the torus is at 6, which tells us that the inner tube radius is 2. So which is given by this equation up here, root of y squared plus z squared minus 4 squared plus x squared equals to 4. And we can basically just get that by doing the similar thing that we would use to isolate a plane equation, right? And Desmos has this interesting feature for number 3, where it asks us to plot it with only these restrictions in place, right? Desmos has this interesting feature which allows us to just put bounds in curly braces. So we have basically just all of those 3 bounds here, which is given by this little purple part of the torus that you can see down here, right? So this is, please stop spinning, jeez. We can see that this is z is less than 0, y is greater than 0, and we can also see that its x is greater than root 2, right? So if I turn off the blue one, which was the whole torus, you can see this more clearly, right? X is greater than root 2, right here, right? Y is greater than 0, right? And z is less than 0. That's pretty much it for this for the tech demo. I think my favorite question of this one was number 1. Really interesting field line right there. So yeah, all right. Thank you very much. Hope to see you again later.